Professor Gail Taylor is the chair of the Multidisciplinary Strategic Research Group for Energy here at Southampton University, and one of her world-leading bioenergy research projects looks at developing a model to predict yield in non-food bioenergy crops. The project uses existing process-based models, including one called Forest GrowthSRC. Gail, in a nutshell, what is the Forest GrowthSRC project about?
Well, Forest GrowthSRC is a model. It's a process-based model that essentially describes and predicts the yield of bioenergy crops. And it does this by breaking down the hundreds of processes that contribute to yield. So, for example, photosynthesis, light interception, the way the plant utilizes carbon. It breaks these processes down, describes them, builds them back up, and then predicts yield.
I see. The project estimates the effect of land use change to second-generation energy cropping on UK carbon emissions, and I'd like to ask about who will benefit from the project and how, in fact, who will benefit from forest growth generally.
Well, there are three types of users or stakeholders that really benefit from our research. The first is academia, so by making our model better, by describing the processes better and making it more accurate, we can ask a lot of what-if questions. What if the climate changes? What if carbon dioxide concentrations rise? And we can answer those questions with the model. And then policymakers are very interested in the answers that we get. Policymakers want to know which non-food bioenergy crops are sustainable and where they might be grown in the UK and where they might be grown more extensively in Europe. And so policymakers from DEC and DEFRA are interested in the outputs of our research. And then finally, we often get approached by industry. So most of the energy companies are investing in renewables, including bioenergy, and they're also very keen to identify where bioenergy crops can be grown sustainably, where they don't compete with food crops, and how much yield they're likely to get. So there are three types of stakeholders interested in our research.
You work with the Software Sustainability Institute on this project. Can you say a bit about them and what is the goal of the work you're doing with them?
Well, that's a really exciting development which has come about in the last year or so. It's come about because of the multidisciplinary nature of what we do. We have some world-leading computer scientists at Southampton, and SSI gives us an opportunity to work very closely with them. And so our model at the moment, it's pretty geeky and pretty clunky. It's several hundred lines of code. It's very difficult to run. A model run takes more than 30 hours. And we're really struggling. It's written in Fortran. It's a difficult thing to use, and it's very cumbersome. And so SSI are stripping down the model. They're trying to simplify the code. They're going to put a nice end-user front face to the model. And so by making it simpler, more people can ask these what-if questions. So the ideal situation in the future will be if this model is run as an app or on a handheld device. Anyone can come along and plug in a few variables and get the outputs of yield and greenhouse gas mitigation potential for these bioenergy crops. So that's really a fantastic opportunity that we're able to take use of at Southampton.
Yes, and that's truly multidisciplinary research and collaboration. And so what are your plans for Forest GrowthSRC in the future after the work with SSI is finished?
Well, in the immediate future, we've just been awarded another grant. That's from the Engineering and Physical Sciences Research Council. It's part of the Supergen Bioenergy Hub. And in that project, we're taking a systems approach. So our part of the project is to supply this model and to supply yield data and also a wide range of ecosystem services. So the benefits that we get from growing different crop types and different land uses in the UK. So we supply those outputs to the systems model, and then the model is called a biomass value chain model. We then use those as inputs to the value chain model. So we can define for the UK what the best scenarios, what the best uses of biomass might be. So for example, is it best to use biomass for liquid fuels? Is it best to use biomass for heat and power? Is it best to use biomass with carbon capture and storage, or to co-combust with coal in coal burning power stations? So that's the end point of this particular work, and that's how the SSI work will move into a bigger systems-based approach.
Thank you very much for your time.